Nothing in the engine bay can be routed or positioned until the cowling is on, because the cowling sets everything else's geometry. So before I could touch the coolant lines, the intercooler, or the oil system, I needed to close out the cowling first. That turned a single item into a 2 weeks job. So this is everything firewall forward over the last 2 weeks. I'll walk you through it. The cowling attached to the airframe with Camlocs. I've previously drilled pilot holes in the cowling to match the Camlocs positions pre-drilled to the airframe. So I enlarged all the pilot holes with step drill to about half an inch, then used a Dremel with a sanding tip to creep up the final fit until the socket drops in cleanly. Drilling and sanding the fiberglass creates a huge amount of dust. The engine bay needed vacuuming after each one. The Camlock socket goes in with 3.2 mm countersink rivets, and the Camlock latch goes in with a specialty tool from our store. And I did these one at a time. Fully installed a Camlock pair before drilling to the next hole. Slow, but I didn't want to have any cascading errors when drilling multiple holes. With all the Camlocks in, I checked the cowling tip to prop hub clearance. Minimum is 5 millimeters per slings instruction. I was at 4.8, so I needed to fix this. The fix is to sand the cowling tip back to 5 millimeters and rebuild the structural thickness with a fiberglass epoxy. It's on my to-do list before final closeout. Inspection doors. There are two of them with piano hinge, each with their own camlocks to secure onto the cowling. The camlock holds on both sides of the inspection door and the cowling are very close to the edge, so the drilling margin is tight. Each door took about 90 minutes, grind, test fit, grind again. You just can't rush composite fitting. Next thing on the list is the top cowling louver. Installing the louver is the same process, just with more iteration. Mark the high spots with a marker, remove the material, and fit again until the whole perimeter sits flat. Then I countersink and rivet. It's not complex, it's just tedious. And the bottom bracket that holds the cowling with two cam locks had a conflicting manual instruction between the latest version and the earlier revisions. So the older version on the instruction said the bracket's flat side should actually be on top, while the latest version said the opposite. I test fitted both orientations, and the geometry made it pretty obvious, at least in my case. I chose to go with flat set up. I then primed, painted, and riveted the bracket in place, and I installed the camlocks. That finishes about 80 to 90% of all the composite work on this entire airplane. I think I'm done with fiberglass for a while. Moving on to the coolant system. The coolant radiator mounts to the inside of the lower cowling via two latch locks, half on the radiator and half drilled into the composite. The challenge here is locating the cowling side holes. So I'm working from inside of a curved fiberglass shell with no flat surface to center punch from. The tool I came up with is a pair of tweezers with the tips bent 90 degrees inwards. So when I hold the latch receptacle in position with one hand and push one tip through the existing holes on the near side, the opposite tip on the tweezer automatically lands on the far side at the correct position. So I just transferred that mark, drilled on the outside, and it worked pretty nicely. Once I was able to locate the holes to drill, the rest of the process was trivial. Just drill the hole, sand, install the latch, radiator is in. Once I have the radiator temporarily installed, I started to fit the coolant hoses. The pre-bent silicon lines from Aerospace Innovations are made specifically for these TSI so they're mostly ready to go. The exception is the coolant overflow. The cap nipple is too recessed for a standard clamp plier to grip. So I called Sling and asked them how the factory handles it. Turns out they switched to locking wires on that particular connection because the toolings can't reach. But I went with a constant tension clamp. In my opinion, it's more secure than a locking wire. Onto the main coolant circuit, engine to radiator, and in the middle there's a T-split to route some of the coolant into the cabin heater. The sections running near the exhaust get a 1.5-inch heat sleeve from Summit Racing. I also made rubber spacers to keep the hoses off bare metal and separate from wiring. It's just chafe protection for overtime. And the cabin heater hose clamps at the rear of the engine are genuinely very inaccessible. I got one arm in and did it by feel. They're in, but it took almost the entire afternoon. But finally, the cooling system is closed. Intercooler is the next. The 915 IS engine is turbocharged, so there's a charge air cooler between the turbo outlet and the throttle body. It mounts just forward to the firewall with a fiberglass composite shell around it. Getting it in requires relocating the pop-off valve and rotating some hoses. The 3/4 inch hose at the base of the pop-off valve has to be rotated 90 degrees or it will conflict with the cowling. It's 4 M5 hex bolts. I just loosen them, rotate, retorque to 5 Newton meters. It wasn't hard, it just had to be done before the intercooler can see properly. For the 2-inch intercooler hose themselves, they need to be cut to length. Throttle body to pop off to the intercooler outlet, and intercooler inlet to the turbofan. The goal is to finally position the intercooler parallel to the firewall with about 100 to 150 millimeter distance. This part was a little nerve-wracking. You're modifying a hose that was already routed, and you can't add material back. I cut a few millimeters at a time and test fit each pass. When installing the composite shell, I ran into typical fiberglass issues. It doesn't fit. The shell needed one corner trimmed slightly before it would sit fully. The two idle clamp and angle bracket assemblies attach intercooler to the engine mount. As I add more parts into the engine bay, the access for adding any new things became tricky exponentially. For the two brackets holding the intercooler, it took me probably 30 minutes or even more. After that, assembling the air filter on a table off the airplane was like 45 minutes. There's a center hole with 6 millimeters bolt, filter into the housing. There's a nut on the back and done. I really appreciate the easy ones. The 915 dry sump oil system runs 5 lines: engine left to tank, engine right to tank, tank to cooler, cooler to pump, and pump back to tank. The PTAP lines from Aerospace Innovation are pre-cut to length and have heat sleeve pre-installed, so that cuts the installation time significantly. And the cooler's straight fitting need to be converted to N8 before mounting. So I mounted the fittings with Loctite 577 O-rings and torqued them to 25 Newton meters. And I needed a deep socket large enough, roughly about 27 millimeters, to tighten the fitting here. My usual ones were all just too small. And for the oil cooler, it's mounted to the lower cowling in the same way as the cooler radiator. There are two latch lock that require some drilling on the cowling in order to mount. I used the same tweezer marking technique to get this done. But for some unknown reason, the progress on the oil cooler was much slower than the cooler radiator when I was drilling even though they are same type of work. It took me about a couple hours of fitting before I was happy with the whole locations. After that, I started to connect the lines to the engine. Left side under the engine was straightforward, but right side took about 2 hours or even more. The fitting is just buried behind it, a lot of things, and there was no access for me to get the connection started. So I temporarily pulled some idle clamp that was there that's causing the interference, and also rolled back the heat sleeve on the line. That gave me maybe about 5 millimeters, which was just enough to get the clearance and get the connection started. And both sides are connected but not final torqued. So I want to do one clean pass when all the lines are ready in their final position. While all of this was happening, I had a tech counselor visit from Jason, a free service through my local EAA chapter. This is his fourth visit to my shop during the airplane build project. I didn't start this project with experience, and EAA's Tech Council's expertise absolutely helps make the project back better quality. During this visit, I got a few pieces of advice from Jason. So first, swap standard nylon zip ties near the firewall to tab cell. They don't degrade in heat. Secondly, firewall penetration ideally should be sealed by metal, not just covered by the fire shields. The shields can move. And there are a few wire runs that can be done better for anti-chafing protection. There's nothing major, and I'll work on this in the following days. After a few weeks of intense work, I currently have my cowling closed, cooling system done, intercoolers in, oil systems in. Next, I plan to work on proper firewall sealing, final torque on all the lines. Then I'll move on to propeller and the fuel and the wings. Thanks for watching. See you next time.